Now we come to talk about the first two random, discrete random distributions that we're going to talk about in this chapter. It's Bernoulli and binomial. So let's start with Bernoulli distribution. Okay, so for Bernoulli distribution, we're talking about trial having two outcomes, either success or failure. So sometimes it's labeled as success, failure, sometimes it's labeled as 1 or 0, and sometimes it's like yes or no. Okay, but regardless, you only have two outcomes. And I guess also if we're doing like a flipping a coin, then it's also a Bernoulli trial because you can only have either head or tail, okay? So if you're working with this kind of random variable, okay? Or I should say with this kind of experiment when you have two outcomes, then we're gonna determine or denote the random variable X to be the number of success in a single trial, okay? So again, we're only doing a single trial, so of course, random variable can only take value of 1 or 0. Okay, either you get a success or you don't get any success. So for definition, random variable X has a Bernoulli distribution if the probability of X equals to 1 is P, and then the probability of X equals to 0 is 1 minus P. Okay, so P, which is a probability bounded below by 0, bounded above by 1, we call it as the probability of success. Okay. So this is the definition of Bernoulli distribution, okay? And we're talking about this random variable X following a Bernoulli distribution with success probability P. So the PMF, okay, as we have shown in the definition actually, so a lot of times you will see that we're using this kind of notation. Random variable follows a particular distribution. In this case, BER stands for Bernoulli, and it has only one parameter is the success probability, okay? So as soon as you see this, what this means is that the PMF of X is P1 equals to P, because the probability, right, of X equals to 1 is P, and then the probability of X equals to 0 is 1 minus P. It is founded it was found by the Swiss mathematician Jacob Bernoulli, so it's named after him. Okay, so you might be wondering, what are possible examples out there for Bernoulli distributions? Okay, so earlier I was saying that, well, if you're flipping a coin or tossing a coin, if it's a fair coin, then if you define success as getting ahead, then it is a Bernoulli distribution. Okay, the random variable is a Bernoulli distribution of one single trial, and then the success probability is 0.5. Okay, in fact, like the second example here, we can also define, like I guess you can turn a random variable into a Bernoulli if it works out. For example, even though we're like rolling a 6-sided die, okay, so you can get 1 through 6, any of the 6 values. But if we define, okay, the success as obtaining a 6, then it is a Bernoulli distribution, and the success probability is 1 over 6. Okay. Lastly, earning an A for this class for any student, then it is a single trial. Okay. And then earning an A, well, if we define that as a success, then the success probability is anything between 0 and 1, and it is a Bernoulli distribution. Okay, so to wrap up our understanding about Bernoulli, I will throw out an example here. Find the mean and variance of X if X follows a Bernoulli distribution. Okay, so again, what we need to know is that the expectation, okay, is summing over, right? All of the X times PX, okay? Where PX is greater than 0, okay? And then the variance, just to refresh your memory, the variance of X, well, we always use that simplification. If you remember, we have expectation of X squared minus the square of the expectation, okay? All right, so with those in mind, okay, let's just work it out. Okay, the expectation of X, okay, we know it only takes two values, 1 or 0, okay, with respected probability over here. So once you do the simplification, this expectation actually is just P. Okay, for the variance, okay, we go with this simplification. Okay, so here we already worked out from the previous step about expectation of X is P. Okay, so here we need to find the expectation of X squared, which is A, again, expectation of a function of the random variable. So we do 1 squared times P plus 0 squared times 1 minus P. And then we minus, okay, expectation squared. So once you do the simplification, it becomes P times 1 minus P. Okay, So this is actually some known result. And given that we know how to compute the mean and the variance, we're actually able to show the expectation and the variance of the Bernoulli distribution. All right, to recap, based on what we have covered so far, we have the variance definition, okay, and then we have also the simplification that people usually do, okay, definition and simplification, okay. If it's a linear function, variance of ax plus b, it will just become a squared times variance of x. If you have a constant, then the variance is always 0. We also define standard deviation as the square root of the variance. And then lastly, we introduce the Bernoulli distribution, okay, with PMF. Success probability is P. And then if we, just like the example just now, we did the mu, the mean of it is P, and then the variance of it is P times 1 minus P. Okay, so that's all for this part.